I appreciate your determination. Welcome back to Type Classes. I am Daniel, and in this video we're going to further practice type classes with a small library for JSON serialization. So let's create a new Scala app in our Part 4 implicits package. So go ahead and create an app called JSON Serialization. Make this an object, of course, and as usual, extends app. So let's keep our little imaginary social network use case that we worked on in the past few videos. And let's imagine we have things such as users, posts, feeds, that kind of stuff. And because we're backend developers, we want to serialize those to JSON so that we can pass them to our front end or in between our multiple services if we want to work on a microservice architecture. So let's say we have some case classes here that will define the data structures that we want to serialize to JSON. For example, we have users with a name and an age and an email, which is of type string. That's one. Another case class that we can define is a type called post with a content of type string and created at, which is of type date. That should be a Java util date. And another case class called, say, feed, that takes a user, which is of type user, and a list of posts as a list of post. So feed takes a user, which is the owner of this feed, and posts, which is a list of these post case instances. All right. So say we have to serialize these three things to JSON. Now, because our code base is absolutely huge, it would not make sense to write implementations here in the case classes themselves because we want this to be extensible and we want other people to be able to write to our code base. All right. So we have decided to use the type class pattern. So what are we going to do? Well, the steps here will be first to create some intermediate data types, which could be stringified as JSON from string, int, and the primitive data types such as date. All right, so we want JSON serializable data types for int, string, list, date, that kind of stuff. Then we want to create type classes or a type class for conversion from our normal Scala case classes to our intermediate data types. And then serialize those intermediate data types to JSON. Okay, so we are going to implement a small sealed trait. We're going to call this JSON value, and this will have a big method called Devstringify, which will return a string. This will be the intermediate data type representation. So this will start the hierarchy of our intermediate data type. Then in step 2, we are going to create type classes or a type class to convert these three things to some implementation of JSON value. And then once we have serialized those three things as implementations of JSON value, then we can simply call the Devstringify method on our result and turn our three things to a JSON string that we can then send to our other microservices or back to the front end. All right, so this is our plan. 3 big steps. Let's start with the first. This is going to be the easiest because we are going to implement the JSON value trait for some int, string, list, and say date data types. All right. So we are going to create a final case class. We're going to call this JSON object. And this will take some values as a map between string and JSON value. and this extends JSON value. This will be the intermediate representation for the kind of object that looks like a JavaScript object saying name John and age 22 and friends, and this is a list, and the latest post is another object which has a content of Scala rocks and date whatever today is, and so on and so forth, right? So this is a big object. The string here will be the key of each of the attribute, and the JSON value is the value of each of the attribute, and the JSON value may of course be an array, a string, a number, another object, and so on and so forth. Okay? Cool. Let's also define a final case class. Let's call this JSON string for the simpler data type, and this will contain a value of type string. This extends JSON value. Then a final case class JSON number with a value of type int, just for the sake of the example. So this also extends JSON value. And we also need an array type. So we can also create a case class. We can name this JSON array. And the values here are going to be a list of JSON value. A list, again, for our own mental sanity, and this extends JSON value as well. So we have our intermediate data types here, and we need to implement our Devstringify method in each. Now for a JSON string, the implementation of the Devstringify method is going to be fairly simple, and is going to be the same string with some quotes at the beginning and at the end. So I'm just going to put in a quote plus another quote, escaped of course, and just put in the value here. Of course, I'm not taking into account the weird case where the value here might also have quotes itself, because I need to escape those, but for the sake of example, this will do. For a number, of course, the Devstringify method is also super simple. I'm just going to call value to string. There are no quotes needed. For JSON array, this is interesting, but I'm still going to use kind of a one-liner. So I'm just going to say values map underscore to stringify. All right, so I have a list of strings now, and I'm just going to say make string. And the make string takes a beginning string, an ending string, and of course a separator. And I'm just going to put in a comma. As for the JSON object, the Devstringify method is going to be values map. And I'm going to put in a partial function here. And the map, of course, maps over all the pairings. So each pairing will have a name and a value, or a key and a value. Okay? And for each of those, I'm going to put in a small quote plus the name, or the key, like I said. All right, so the quotes here, and then a colon. And then I'm just going to say plus value dot stringify. Okay, and then I'm just going to add the makeString method again. And makeString in this case for the JSON object is going to begin with a curly brace. It's still going to have a comma, and it's going to end with a curly brace. So let's test our little API here. So if I create a data value, which is a JSON object, with a map with, let's say, user is a JSON string with, say, Daniel, and posts is a JSON array with a list with, let's say, 2 posts. Say a JSON string with Scala rocks, because it does, and a JSON number with 453 with the number, and a comma in between so that our code may safely compile. And if we print line our little data.stringify, we should be seeing a JSON object with user:Daniel and posts: an array, which starts with a square bracket, and we can have a small string and a small number inside. So let's run this and see what happens. So we have user:Daniel and posts an array with Scala rocks and 453. So our little serialization here with our intermediate data types works fine. So our first step is done. Second step is doing type classes. And as we saw in the last few videos, we have 3 fundamental things that we need for type classes. First, we need the type class itself. Second, we need type class instances, which are implicit. And then we need a method to use our type class instances. And I will go with the conversion route. All right, so this is pimp library to use type class instances. So let's do these in turn. How would our little type class look like? Well, it would be a simple trait. And I'm going to call this JSON converter. This takes a type parameter, as most type classes do, and this has a simple method, say convert, which takes a value of type t, in our case users or posts or feeds or that kind of stuff, and it will convert that thing to a JSON value, depending on what that JSON value is, either a list or a JSON object or a simple string or what have you. Okay, so this is our type class. So this is step 2.1. Step 2.2 is to define our small type class instances. And let's define some. I'm going to define an implicit object, say string converter. This extends JSON converter with type string. And the def convert here will convert a value of type string into a JSON value, and this is a piece of cake because we already have a JSON string with that value. Okay? So this is one. Another one is an implicit object, say int converter or number converter. This extends JSON converter with type, say, int. Okay? And the same thing applies. Def convert a value of type int to a JSON value. Again, piece of cake, we already have a JSON int, or JSON number we called it. And we're going to pass the value inside. Now, for our custom data types, so these are for existing data types. Now, for our custom data types, we must write implicit converters for users, posts, and feeds. So let's create an implicit object. Let's call this user converter. And this extends JSON converter with user. Of course, we also need to implement the convert method with a value of type user to a JSON value. But this time, we'll return a JSON object. So this is going to be a JSON object with a map, of course. And this map will take the name, and as a value, we are going to create the JSON string with user.name. Let's call this user because it's more suggestive. And let's use user.name, comma, and then an age, which in this case is a JSON number with the user.age, because this is an int, and the email, of course, with a JSON string with user.email. Okay, so this is our user converter. Write another one. Implicit object. I think you are starting to get used to this by now. So post converter extends JSON converter with post. Okay, and again, the defconvert method with a post of type post. This returns a JSON value, and this is again a JSON object with a map. And what do we have? We have content and a created at. So let's get back to our implementation here. So we have the content as a JSON string with post content and a comma, of course, so that we don't forget, and the created, which is a JSON string with a post.createdAt.toString. Okay, so that's post converter. And finally, we have an implicit object, which is a feed converter, extends JSON converter with feed. Okay, and the defconvert will take a feed of type feed with capital F, and this will return a JSON object as well. This will also take a map, and the user here, and this is interesting because it will be a conversion of a user. So we should say something like user converter dot convert feed dot user. This is quite clunky, and I'm going to add a to-do here because there is going to be a refactoring that we are going to do. Very simple, but I'm going to add a marker here. So I'm going to add a comma, and what was the name of the, okay, posts. Okay, so posts is going to be a JSON array, and the values here are going to be feed.posts map, and for each post we are going to do a post converter.convert. Okay, and of course we can eliminate that because the compiler will do a functional lifting for us. But again, we have this clunky post converter.convert, which makes our feed converter depend on the exact implementation of post converter. This is an unnecessary dependency. So I'm going to add another marker here. So these are our type class instances, okay, for existing data types and for custom data types. Now the third step is conversion. So I'm going to have a small conversion class as an implicit class. I'm going to say implicit class JSON ops or JSON enrichment. I'm just going to name this JSON ops. Both ops and rich or enrichment are used in practice, so this naming is pretty standard. So I'm going to name this JSON ops, and I'm going to take a value of type whatever, and this type will be used as a type parameter, and this will have a small method to JSON, which will take an implicit converter, which is of type JSON converter for type T, and this will return a JSON value. And the implementation is going to be super straightforward as converter.convert value. All right, so we have our type class pattern already implemented. So let's use it by calling stringify on a potential result. So say, for example, I have a small date, let's say now, which is a new date of system.current time millis, so that we don't have to deal with the date in the future posts. Let's use our little John user as user with John 34 and John at rockthejvm.com, And let's say we have a small feed, which is a feed of John's, and a list of posts. And we have a post with, let's say, hello and the date now, and another post with look at this cute puppy, and also now. Okay, and let's print line finally feed dot to JSON dot stringify, which is my favorite part of the show. So feed to JSON stringify makes use of all the magic that we wrote so far. So if we compile this and run, we should be seeing a cute little JSON with user and the user's JSON serialization, name John, age 34, email, whatever, and the posts as an array of things, and each thing is its own JSON serialization with content hello created at whatever, and content look at this cute puppy created at whatever. So we have a magic to JSON method that converts our data types to an intermediate data representation, and then we later can call stringify on that result. All right, so this is pretty darn cool. Now, I promised I would come back to these to-dos and solve them in due time. So let me do that, and I'm going to hack this. I'm going to put the 2.3 part before the 2.2 part. And having defined a JSON ops before, I can relinquish the dependency on a specific implementation of converter, and I'm just going to call feed user to JSON and let the compiler fetch whatever the implicit representation is appropriate for me. And I'm just going to say JSON array feed posts map, and instead of post converter.convert, I'm just going to say _.toJSON. And that, my friends, will be it. And if I run this again, I should be seeing the same result. So this is pretty freaking awesome. We wrote an extensible JSON serialization library in like, what, 20 minutes? And we've also practiced the type class pattern. So having written this basic code, feel free to expand it with some JSON prettifiers and extra data types and whatever you think is fun. I'm Daniel, and after you're done playing, I'll be waiting for you in the next video.